All right, for lesson 14.3, we are going to look at combining like terms. So up until now, you've been doing 1 and 2 step equations, but we have to back it up a little bit and look at expressions before we move on to any more complex equations. All right, an expression is a mathematical phrase that uses numbers, variables, and operational symbols. Now, notice it does not have an equal sign. If it had an equal sign, that would be an equation. So 2x plus 7 is just an algebraic expression. And we're going to focus on just simplifying and combining like terms and expressions before we move on to equation solving. So let's take a look at some vocabulary before we get started. Hopefully you all watched the Chuck Norris video about combining like terms. If we were in class together, I love to sit and talk over this video while they're going through it, but I hope it made sense that you just can't combine whatever you want. You have to combine like things. So in that video, they were objects. They were Chuck Norris, right? But in ours, we're going to look at different variables and numbers and see what we can combine, and we can only combine it if they are like terms. But what do I mean by that? So we need to figure out what are the different parts of an algebraic expression. So the first part here are the terms. The terms are these separate pieces that we're looking at. So 5x is a term, negative 6y is a term, and 3 is a term. This plus just means it's a positive 3, so I would just say 3 is my term. Now, terms can consist of numbers and variables or the product. What does product mean? Multiply, hopefully remember that. So this 5x is really like 5 times x, but we just write it as 5x. Negative 6y is really negative 6 times y. So that's why it is a product. We are coupling it. It is a single term. Single term. All right, now coefficients. Notice, only these two numbers are coefficients, not 3. Coefficients are the numbers before a variable. So they're the numbers out front of the variable. So the coefficient of x, if I would ask you, is 5. What is the coefficient of y? Well, it's negative 6. The coefficients are the numerical value that is being multiplied by the variable, the number out front. The variables, we've talked a lot about variables. You've seen variables in the 1 and 2 step equations. They just represent unknown values, values that we can solve for. They can change. So those variables are oftentimes what we are solving for. But just to make sure that we understand the vocabulary of what is in an algebraic expression. Now, the last thing, we've really accounted for everything. 5 and negative 6 are the coefficients. X and y are the variables. So what does that make 3? Well, 3 is a constant. It does not have a variable. It is just a number by itself. So it is a constant. All right, let's take a look at what it means to have like terms. So we're going to focus over here on this column first. 3x and negative 2x are like terms because they both have the variable x in them. So we could put them together if we wanted. Now the next one, negative 2 and 5, are both like terms because they're just constants. They're just numerical values. Same thing with 101. Now I want to look at this last one. That's a little bit different, right? We have 3xy. Whoa! Then we have 4yx. But really, we still have the x and we still have the y, and they're being multiplied together. So I could rewrite that as 4xy. Now we can see we have the same variables, x, y, and then we have those coefficients out front. Now, this is supposed to say not n times 2. It's supposed to say 9n squared and 3n squared. So that's a little bit confusing. But the variable n is to the second power in both of these terms. That is what makes them alike. Now, in contrast over here, we have 9n squared and just 2n. Even though they both have the variable n, this one has an exponent of 2. Therefore, these are not like terms. Not like. Now, let's go through and look at why the rest of these are not like terms. So 3x and 3y. Sure, the numbers are the same, but that doesn't matter. The variables need to be the same, and they are not. So those are not like terms. In the next one, we have just a numerical or a constant value, and then we have 5x. There's no x in that first one. Those are not like terms. And then the last one, again, my exponents didn't transfer here. I have 2a squared b and then 3ab squared. Now, I have an a, but this a has an exponent of 2. This one would have an exponent of 1. Vice versa. The b has an exponent of 1 and this b has an exponent of 2. Those are not like terms then. So you have to be careful. We cannot just combine anything. They have to be like terms before we can combine them. All right, so take a look at this expression. Pick out the like terms. All right, we have 3a and negative 6a. To put them together, we add the coefficients in the front. So what is 3 plus negative 6? Well, it's negative 3, and then a. Our variable still remains a. Now, usually mathematicians go in alphabetical order when simplifying expressions, and they leave the constant for the end. So I'm going to skip to the b's. I have 5b and negative 2b. What is 5b plus negative 2b? Adding the coefficients, 5 plus negative 2 is 3, and it's b. Think of it as if you had 5 balloons, and you took away 2 balloons. How many balloons do you have left? You have 3. So that's where I'm getting the 3b from. And then the last one here, we have negative 7 and positive 10. Those are my constants, so I'm going to write them last. Negative 7 plus 10 is 3. So for right now, that is our simplified expression. When you go on into other courses, we can do what we call factoring that expression, but we are going to go ahead and stop here. Now let's take a look at some examples. Again, we have two k's here, right? It's negative 6k and 7. We need to add the coefficients, and our variable remains k. So negative 6 plus 7 is 1. Now, the more simplified version, if I just have 1k, can't I just call it k? Yeah. All right, let's take a look at another one where we have 2 going on. We just have an n out front here. So if it's just n, how many n's is that? It's 1 n, right? So I'm going to go ahead and put a 1 in there just to remind me that that represents 1 n. 1 n plus 9 n's is a total of 10 n's, or 10n. Ooh, now this might be tricky. What's negative 10 plus negative 3? Negative 10 plus negative 3. So if we go to negative 10, then we need to go negative 3 more. So that would be negative 13. So that would be my most simplified expression. All right, why don't you try the next one on your own? There are no other r terms, so we do 12r. Now we combine the numerical values, or my constants. What is negative 8 minus 12, or negative 8 plus negative 12? Negative 20. Now I have the term with an r variable, and I have a constant. I cannot combine any further. That's as far as I can go. All right, and then the last one, negative 4x plus negative 10x. How many negative x's do I have total? I have negative 14 x's total. All right, if you're feeling good, I say pause the video and try to do these on your own. Then go ahead, play it, and check back in with your answers. All right, on that first one, I put a negative 1 in front of the r. Since it is just negative r, that really means there's one of them. So a total of negative 11r. The next one, 4x plus 11, combining those x terms, and then I have my constant of 11. Now the next one, number 7 here, 11r minus 12r. So what is 11 minus 12? Well, it's negative 1 and r, because that's our variable in the term, right? We can also write this as just negative r. Instead of writing it as negative 1r, just negative r is fine as well. And then the last one, there was not a negative 1 in front of the v, so since it was a negative v, I put a 1 there, showing that it represents negative 1. And then negative 1 plus 12 is 11. Variable is v. All right, go ahead, pause here, and try these all out on your own. All right, I'm going to skip down. I want you to check your work. I circled any terms that were like terms that I could combine and rewrote them in the next step. I want to focus on number 13 here. We get 15r. I'm sure you got that. Then 5 and negative 5 is 0. So you could write it as 15r plus 0, but the more simplified expression would just be 15r. We don't need to write the plus 0. That's understood that we're not adding any constants to our expression. All right, let's take a look at this one here, number 12. So I combined my n's to get negative 4n because this would really be like 1n. So that's where I'm getting that negative 4 from. Now, I keep saying it as 4 plus negative 9, which is negative 5. You could have written this as negative 4n plus negative 5 or just negative 4n minus 5. It doesn't matter. Whichever way makes more sense to you. And then number 14, we get 9n plus 1. All right, these are the last 6 examples for this lesson. So I want you to pause again and try these all on your own. All right, in that first one, we get n minus 13. Number 16, you'll see that I added a 1 there because it's really negative 1n. So 4n minus 1n is 3n. Number 17, combining my x terms, negative 3 plus 15 is 12, and it is the x term, and I bring down that minus 9. Now, number 18, when we add those together, negative 9k plus 8k is negative 1k, or like I said in some of those other examples, we can simplify that to just negative k. Either way, whichever one works for you. Number 19, combining those are both negative values, so we have to add those negative values together, right? Negative 16 plus negative 14 is negative 30n. And number 20, subtracting them, we would get negative 4n. All right, that is where we're going to pause for combining like terms. So that is everything for 14.3. You may now do the homework.